All right, let's talk about one of the coolest, most overlooked parts of how your computer actually works, how its super fast brain manages to talk to the, well, much slower world around it.
No, seriously, have you ever really thought about that? You're tapping on your keyboard, and even if you're a world-class typist, you're still moving at a snail's pace compared to the processor inside that box. That thing is thinking literally billions of times faster. So, what gives? How does it not just grind to a halt, waiting for us?
Let's try an analogy. Think of your computer's CPU as this brilliant, hyper-caffeinated CEO. It's making billions of decisions every single second. And you, with your keyboard, you're kind of like the new intern, carefully delivering one letter of a memo at a time. The speed difference is it's insane. There's no way that CEO can just stand there tapping their foot, waiting for each character.
And that's exactly where I/O, or input-output, comes into the picture. It's this incredibly clever, invisible system of assistants and messengers and rules that lets our super-fast CPU work with all the slower parts of the company. You know, the keyboard, the printer, the hard drive, without losing its mind. It's the secret sauce that manages all that chaos.
So let's really get into this great divide. We're going to stick with our busy CEO analogy because honestly, it makes these pretty technical ideas just click. So here are the players in our little corporate drama. You've got the CPU, our impatient CEO. Then there's the computer's memory, the RAM. Think of this as the CEO's personal whiteboard. It's super fast and it's right there in the office. And then you have all the other stuff, the keyboard, the mouse, the storage drives. Those are all the other, slower departments. The whole game, the entire challenge of I/O is figuring out how the CEO can possibly get work done with these departments without wasting a ton of time.
Okay, so to make this all work, any office and any computer needs a really solid internal communication network. Inside a computer, these are basically highways for all your data.
And this network has a name. It's called a bus. The best way to picture it is like the entire system of hallways in a big office building. It's the shared pathway that connects everyone, the CEO's office, that whiteboard room, and all the other departments. It's how information gets from point A to point B.
But this data highway isn't just some big open road. Nope, it's much more organized. It has 3 distinct lanes. First, you've got the address bus. This is like the office number on an envelope. It says exactly where the data is supposed to go. Then you have the data bus. This one's easy. It carries the actual memo, the data itself. And finally, there's the control bus, which is like the traffic cop, managing the whole flow and sending out signals like, hey, get ready, info's coming, or, okay, I'm done sending.
And just like in a real office, not all hallways are the same. The connection between the CEO and their personal whiteboard, that processor memory bus, is like a private, high-speed expressway. It's short, it's incredibly fast, and everything happens in perfect, predictable rhythm. But the I/O bus, that's more like a long public hallway connecting all the other departments. It's slower, and because you have fast things talking to slow things, you need a system of, well, handshakes, basically, to make sure a message from the CEO doesn't just fly past the slow-moving mailroom guy.
Okay, so we've got our hallways. But with all these different departments, how does the CEO make sure a message for the printer doesn't accidentally end up at the keyboard? Well, there are 2 main ways to handle this.
First up is what's called memory-mapped I/O. In this setup, every department, like the printer, gets its own little reserved space on the CEO's main whiteboard. So to talk to the printer, the CEO just writes to the printer section of the board using the exact same commands he uses for everything else. Simple. The other way is called isolated I/O. Here, each department gets a special intercom number. To talk to them, the CEO has to use unique commands, like in and out, that are totally separate from how he uses his whiteboard. And now, we get to the real heart of it. We've got the communication lines, we've got the addresses. But how does the data actually get moved around? This is the CEO's big dilemma, and there are 3 very different management styles to solve it. But first, a really quick but crucial idea. On these data highways, there's always a bus master and a bus slave. The master is the manager. It's the one who can actually start a conversation. Think the CEO. The slave is the employee. It just listens and only responds when it's talked to. Now keep that manager-employee idea in your head because it is key for our third and coolest management style. Okay, management style number 1, programmed I/O, or as we'll call it, the micromanager. This is where the CEO needs to send a big report to the slow printer department. So the CEO sends one page and then immediately asks, "Are you ready for the next one?" The printer, of course, isn't, so the CPU just waits. It gets stuck in a loop, constantly asking, "You ready yet? How about now? Now?" This is called polling, and it is a colossal, criminal waste of the CEO's time. Thankfully, there's a much smarter way. Style number 2, interrupt-driven I/O, the reactive manager. Here, the CEO gives the whole report to the printer department and just says, "Hey, let me know when you're done." The CEO then gets back to doing other critical, high-level work. Once the printer finally finishes, it sends an urgent memo, an interrupt signal, back to the CEO. The CEO just pauses what it's doing for a second, acknowledges the job is done, and gets right back to work. No more waiting. So much better. But what about the really, really big jobs, like moving a massive file from a hard drive to the main whiteboard? Even with interrupts, the CEO still has to be bothered for every single transfer. That's a bottleneck. And that brings us to the ultimate delegation strategy, direct memory access, or DMA.
This is peak efficiency. With DMA, the CEO gets to hire a super competent personal assistant called the DMA controller. The CEO just gives the instructions one time. Move this entire file cabinet from the storage department to this section of the main whiteboard. Don't bother me again until the whole job is done. And that's it. The DMA controller becomes the temporary bus master, takes over the hallways, manages the whole transfer, and leaves the CEO completely free to focus on big picture stuff. It's beautiful.
All right, so now that we've got a handle on how computers manage all this data flow, let's connect it to a real-world tech you've probably heard about that makes your data storage way faster and safer.
And that technology is RAID. It stands for Redundant Array of Independent Disks. The idea behind it is actually pretty simple. Instead of just relying on one hard drive, RAID uses a whole team of drives that all work together. To your computer, it just looks like one big drive, but behind the curtain, a RAID controller is managing that team to hit some very specific goals.
Let's just look at the two most common flavors. On one hand, you have RAID 0. This is all about speed, pure and simple. It uses a method called striping, where it splits the file into pieces and writes those pieces across multiple drives all at the same time. This is blazingly fast. But, and this is a big but, there's zero backup. If even one of those drives fails, your entire file is gone. Poof. On the other hand, you have RAID 1. This is all about safety. It uses mirroring. Every single thing you write to the drive is instantly duplicated on a second drive. It's not any faster, but if one drive dies, no problem. You've got a perfect identical copy ready and waiting.
So when you boil it all down, the entire story of I/O, from that painful micromanagement of programmed I/O all the way to the genius delegation of DMA, it's all been about one single goal. It's about building a management system that frees up that brilliant, fast-thinking CEO, the CPU, to do the one thing it does best: think really, really fast.
And that kind of leaves us with a really fascinating question for the future. As our data needs just explode, we're talking massive video files, huge AI models, you name it. The pressure on these I/O systems is getting intense. So what's next? What new, even cleverer forms of delegation are we going to have to invent to keep our CPUs from getting bogged down? What will the next generation of these personal assistants for our CPUs even look like? That's the big challenge, and it's going to be exciting to see what comes next.